We will finish out our study of manipulating algebraic expressions in Unit 1 by working with rational expressions here in Section 1.5. In this video, we'll discuss simplifying rational expressions. In the same way that you have a real number fraction that should always be written in reduced form, we want to apply the same thing to rational expressions. But first of all, what is a rational expression? Here's the definition. A rational expression, notice in the word rational, we can see the word ratio. So a rational expression is the quotient or ratio of two polynomial expressions. A rational expression is simplified when the numerator and denominator do not share any common factors. Again, back to our real number example, 4 divided by 12, the common factor there is 4. So if I divide the top by 4, I get 1. If I divide the bottom by 4, I get 3. And that reduces our fraction. We're going to apply that same principle to rational expressions. So let's try this on example 1. Simplify the rational expression. First of all, observe that we have the ratio or quotient of two polynomials. That is, we have a polynomial in the top and a polynomial in the bottom. So to simplify it, we need to identify common factors. In its current state, we have terms in the top and terms in the bottom, but neither polynomial is factored. So that's going to be our first step. Completely factor the numerator and completely factor the denominator. Looking at the numerator, we can observe there's a greatest common factor of x. So I'm going to factor out an x from the first two terms in the numerator. That leaves behind x minus 8. Also in the denominator, we have a greatest common factor of 3. So if we take that out of the denominator, that leaves behind the factor x minus 8. Now that we can see the individual factors of the numerator and denominator, we can clearly spot a common factor. X minus 8 belongs to the numerator and the denominator, so we can cancel it out. The remaining factors give us the polynomial or the rational expression in simplified form. Because there's no further common factors between the numerator and denominator, we know that it's completely reduced. Okay, let's give this same technique a try on example B. Again, we have the ratio of two polynomials. In order to reduce it, it must be in factored form. So looking at the numerator, we've got a trinomial, which we can break down into two binomial factors. This will give us a good opportunity to practice our factoring techniques. Now we know the first two terms in our binomials have to multiply to give us 6x squared. Well, we've got some options here. That could be 6x times x. That could be 2x times 3x in any order. So I'm just going to make a choice here and choose the combination 2x and 3x. In the last two spots of our binomial, we know those have to multiply to give us negative 5. Well, the good thing about 5, there's only two factors of 5, 1 and 5. But notice because this sign is negative, we're going to have different signs in our binomial factors. So let's pick a pair. Let's put the 5 here and the 1 here. Notice before we choose our signs, the outside product of our two binomials would be 2x, and the inside product would be positive 15x. They do have a difference of 13. That's what we're looking for our middle term. But in order for it to be negative, we need the biggest product to be negative. That's going to be our middle product. So I'm going to make that one negative and this one positive. If at any point you're unsure if you factored it correctly, remember you can always FOIL it out and double check your factoring. Okay, let's look at the polynomial in the denominator. This one is also going to break down into two binomial factors. To find the terms in the first two spots of each binomial, we know they have to have a product of 8x squared. So again, we've got some choices. That could be an 8x times a 1x. That could be a 2x times a 4x. Okay, so just by trial and error, pick a pair. I'm going with 2x and 4x. In the last spot here, to choose the two terms that go in the last two spots of our binomial factors, we know they're going to have a product of 15. So numbers that multiply to give us 15 would include 1 and 15. It would also include 5 and 3. So I'm going to pick a pair, 5 and 3. Okay, and remember, because this sign is positive, the signs of our two binomial factors have to be the same. This one tells me clearly that they're both going to be a minus. So let's just double check by FOIL. The product of our first two terms here would be 8x squared. The outside product would be minus 6x. The inside product would be minus 20x, and the last terms would have a product of 15. If we combine those two middle terms, we would get negative 26x. This matches what we have in the denominator, so we know that we have it factored correctly. Now, it's easy when we're all working together, but on your own, remember, it may take you 2 or 3 trials and a few errors before you get the right factorization. But now that we have it factored, clearly there's a common factor between the numerator and the denominator. The 2x minus 5 matches, so we can cancel that out. Therefore, the reduced rational expression would be 3x plus 1 over 4x minus 3. Your ability to reduce a rational expression depends on your ability to factor. So keep practicing. The more you practice, the easier it gets. And always remember, anytime you're working with a rational expression, it always must be presented in its simplest form, just like we would do with real number fractions.